The effective resistance between the 2 points we have to find, that is effective resistance between the points A and B we have to find, and this is infinite series resistance, infinite combinations of resistances are there. So this is going on up to infinity combination of resistance are there. How to handle these type of problems we are going to discuss now. So whenever this type of problem is given, the first what you have to do means, what is the repeating term you observe. So R, so this term is repeating, same R, that means R, again R, again R. So this term is repeating. So leaving the first term, let us think till here, leave the first term. So the total combination till here, let me take it as some x value. What I did here, please concentrate. I have taken, this is one term, that is R and R, this one combination. Let me take, this is one combination. This combination is repeating R, like that's going on repeating. Now what I am doing here means, I am leaving that first term which is repeating term. The repeating term is R and R. This is the repeating combination. This is like that. It's going on repeating. Leaving the first term, remaining the total. Leaving the first term, remaining total. I am taking it as one resistance. Let me take the value of this resistance as X. Fine. Now let me draw on the diagram. Now here what I did here is I have taken one resistance like this, and this is the combination which is the repeating I told, and this is the point A and B I told. And what I did here, so here this is the repeating term, this is R and R repeating term I told. Leaving this one, remaining the total is I have taken the thing as X. Remaining the total is called as X. Fine. Remaining the total term we are calling it as X we told. Now, one question I want to ask. You have to answer this question. For infinity things, if I have taken some infinite things, answer is X. What is the answer for infinity plus 1 things? What will be the answer? Here the simple logic is, for infinity things answer is X means you must not say infinity plus 1, no sir, answer is X plus 1 sir, you must not say. Why sir? Why you must not say like that? Because for infinity things the answer is X means, for infinity plus 1 things means, what is infinity plus 1 first of all? Infinity plus 1 is also infinity only. That means for infinity terms the answer is X means, for infinity plus 1 terms also answer is X only. For infinity plus 1 terms also answer is X. This is the basic logic. Here, sir, why you use this logic, sir? Because, observe carefully, this resistances combination like that. If you leave the first one also, we call it as infinity. So for infinity terms, leaving the first one, remaining are also infinity. So for infinity terms answer is X means. And we are adding one more thing for infinity, this term for infinity. So infinity plus 1 terms also, the effective resistance will be X. That is the logic. If you understand, these problems are over. Simple logic. That what I told you, I think you have got some idea now. What I told, basic logic, that is for infinity terms, answer is X. So for infinity plus 1 terms, infinity plus 1 is also infinity only, no sir. So then infinity for terms answer is X means, for infinity plus 1 terms also answer is X. If you identify this logic, everything is over. Nothing to get discussed, nothing to get answered. If you have just understood this basic logic. Let us see what is happening here. So now you observe these two. This resistance R and this X, how they are. R and X, they are parallel. They are parallel means I can write now total effective resistance. Let me call some effective resistance of the only this combination. Let me take. Actually, I know one secret. What is effective resistance of this total combination means, if we add for infinity terms, the effective resistance is X. for infinity and this term if you add, then also the answer will be x only. No doubt. For infinity terms x means for infinity and one more term we are taking, then also answer will be x only, no doubt. But okay, that the answer is x. I also know, you also know. What is R effective from these combinations? R effective from the given combination. Observe here. X and R, how they are? X and R, how they are? X and R parallel. In resistances, two resistances are in parallel means what you to write? Rp is equal to R1 R2 by R1 plus R2. This is the formula for parallel combination of resistance we know from childhood. So here R effective means what should I write? R into X by R plus X. R into X by R plus X. Okay, along with that one, now this is R into X by R plus X. Which one? I will not take it completely at a time. I will make it a small parts now. What I am doing here, observe carefully here. This is R and here down nothing is there. This total combination means these two are parallel. That is R into X by R plus X. What I wrote there? R into X by R plus X. Fine. You wrote R into X by R plus X, sir. It is very cool. Then here also one R is there. I want A and B. Fine. Now the total effective resistance. Total effective resistance means, observe this resistance, how they are? This resistance, how they are? Series combination. Series combination means R effective will become R plus R into X by R plus X. Series combination means just addition. We know very well. And here R effective is X. Here R effective is R plus Rx by R plus X. So what should I do now? I can equate both. I can equate both. Now, from here my answer is, what is my answer? X is equal to R plus R into X by R plus X. This problem we can suppose in exam optional verification we can verify like that. No sir, we don't have any options like that, means what should I do? X is equal to LCM. LCM means R square plus RX by R plus X. What you did, sir? Nothing I did here. This term is there, this term is there. I am taking the addition of these two terms. I have taken LCM. LCM is R plus X. Here R into R square plus RX plus RX. And multiply, cross multiply means Rx plus X square is equal to R square plus Rx plus Rx. Now one thing I can say here, Rx they are common and they can be cancelled. So what are the remaining terms? X square minus Rx minus R square equal to 0. Sir, how did you write like that, sir? What I did nothing here. Just I took R square to LHS side, Rx to LHS side. I got X square minus Rx minus R square is equal to 0. I hope you are clear with this formula. Now, let me take a first page here. X square minus Rx minus what I have, R square is equal to 0. Sir, why you have taken this one, sir, like quadratic equation? It looks, no, sir. Yes, it looks like quadratic equation. I heard quadratic equation means ax square plus bx plus c is equal to 0. Fine, ax square plus bx plus c is equal to 0. You told, sir, very nice. What is x? X is equal to, in quadratic equation, we can write roots of quadratic equation means b square minus 4ac by 2a I can write. So quadratic equation, this is the roots of quadratic equation formula, minus b plus square root of b square minus 4ac by 2a. Sir, here plus or minus is there? Yes, plus or minus is there. What is there in that term? Now, in this equation, what is A? A value here, nothing is there means I have to call it as 1. Here B value is minus R, C value is minus R square. So, what should I write? Minus of B value. What is B value? Minus R. B value is minus R. Here again, what should I write here? B square. That is nothing but what should I write? Minus R whole square. Minus 4 into A value. What is A value? A value is 1. A value is 1. And C value. What is C value? Minus R square. C value is minus R square. So minus R square, if I keep in this square root like that, by 2 into A. What is A, sir? Here A is nothing but A is nothing but 1. So 2 into 1. So in the denominator 2 is there. In the denominator 2 is there. Here plus or minus is there. So what should I write now? X is equal to 1 by 2. 1 by 2 you leave it. Minus of minus plus or minus root over. What should I write? R square. Here minus of minus plus 4R square. Understood the beauty of this problem now? Here minus of minus became plus. So what I got, x equal to 1 by 2 into r plus r minus square root of r square plus 4r square. What is that, sir? Nothing better. X equal to 1 by 2 into r plus r minus square root of 5r square, or simply x is equal to 1 by 2 r plus or minus root 5r. How you got this one, sir? Nothing better here. You observe carefully here. 4r square minus of minus plus 4r square plus r square. 4r square plus 5r square. This is 5r square I kept here. So what happened here? Root over 5 into r. This is the formula I got. But is it possible to take minus sign, sir? Minus sign, sir? My answer is no. My answer is no, because we don't have negative resistance values, no beta. We have only positive values, because root 5 is given. Suppose if you observe here 1 by 2, or if you take outside 1 plus or minus root 5. Root 5 is greater than 1, then we don't have minus sign. So don't take minus sign here. Or my final answer is r by 2 root 5 plus 1 or 1 plus root 5. 1 plus root 5. This is the answer. I hope you are clear how to handle this type of problems. That is infinite series combination resistances problems. So this is how we have to handle the infinite combinations of resistances. Infinite combinations of resistances. Okay, sir. I got some idea about this one. So here what we got here means, first they have given the resistances like that. What I did here, leaving the first term, for remaining how many are there means, for infinity terms are there. If you leave first term also, the remaining is infinity. For infinity terms answer is x. Now if you combine again with the first term, then also answer is x. Then also answer is x. Generally you will be thinking, by seeing this calculation and everything, will be thinking it will become lengthy. No beta, they will give the numerical values. It will become very simple within the short time. In exam this type of problems you can solve, nothing to worry. So here what I did, till infinity numbers answer is x. You are adding one more. For infinity if you add one more term, what will happen? There also will get answer x. So here these two are parallel. First of all, these two are parallel. These two are parallel means r into x by r plus x, and r is in series. So r effective is equal to r plus rx by r plus x. Fine, sir. I got this one. Now what should I do, sir? What should you do? Simply here both are equal, no beta. Here what happened? Effective resistance is x is effective in this value. I am equating these two. After equating these two, what I did here? I took LCM. After taking LCM, cross multiplication, I got a quadratic equation in terms of x. quadratic equation, roots I solved, and finally I got the answer as x equal to r by 2 into root 5 plus 1. I hope you are clear how to handle this type of problems.